Hey,
Hello.
hello, Francisco Diaz Mazo.
Hello，杰工。
Mhm.
Emergencies.
Lakshmi Viswanathan.
杰工。
Francisco Diaz Mazo.
Great. Okay, I believe it's 5 p.m. Lakshmi, would you like to begin?
Yeah. Hi, everybody. Welcome to our panel. Thank you so much for joining us today for Engineering and Emergencies. My name is Lakshmi, and I'm a senior majoring in civil engineering with a minor in economics. And my pronouns are she, her. And I'm really excited to be here today with my co-moderator, Evan.
Hello, everyone. My name is Evan. My pronouns are he, him, his. I am also studying civil engineering here at Rutgers University, and I'm also pursuing a minor. My minor is in Spanish.
Thank you, Evan. So we are joined today by two distinguished guests. We have with us today Francisco Diaz-Mazo, an alumnus from the School of Engineering, and we also have with us Dr. Jay Gong, a faculty member of the School of Engineering, specifically in the Civil Engineering Department. Thank you, Francisco and Dr. Gong, for joining us. We're really excited to have you guys with us today for our discussion. Can you please give a quick intro of yourselves, including your name and a little bit of what you do?
Yeah, good afternoon to all of you. I'm very honored to be part of this panel and especially being part of the Rutgers institution and everything it did for me. So I'm the president and CEO of a specialty contractor here in Puerto Rico. We're a specialty contractor dedicated to infrastructure work related to water, power, HVAC, and telecom. And basically, we've been in business now for almost 60 years, and we are a local Puerto Rican company.
Thank you. What about you, Dr. Gong?
Oh, thank you for hosting us, and it's such a pleasure to visit all the attendees on the live events here, and especially also with Francisco together, and since we have a lot of common interest. But my name is Jiego. I'm an associate professor in the Department of Civil and Environmental Engineering at Rutgers University. So my current research focuses on disaster preparedness, critical infrastructure protection, and at a larger scale, basically for improving the community resiliencies.
Thank you very much, both of you. Evan, would you like to kick us off with our first question to our guests?
Yeah, so being that this panel is centered around engineering and emergencies, so that field has really taken quite the uptake in importance over the last few years. And being that both of your expertise has lasted a few years, Dr. Gong, I was wondering, how did you originally choose this field and what really drew you to come to Rutgers?
Thank you. Actually, I didn't originally doing what I'm currently doing for the disaster, preparedness mapping. But my original actually training is in the spatial mapping and robotics for construction projects. So in that sense, I think we have a further connection with Francisco's company. So we do a lot of construction projects back in time, doing spatial mapping and using LiDAR and using robotic systems over there. But really, what drive me to join to Rutgers is actually you guys, right? Both are Rutgers engineering students, brilliant students, and also it's on the very dynamic area on the coastline here. So my change over that is shifting from mapping from the construction side to a larger scale to city and community scale, really related to my experience when I just joined the Rutgers. When I joined Rutgers in 2012, it's really just I think 2 months before the Hurricane Sandy lands in New Jersey, and I originally spent most of my time in Texas, Austin. We have no hurricanes can reach that far to Austin. No tornado, very last tornado events. But when we come here, it's like it's really changing my perspective about the spectacular force of wind and the wave. Let me put it this way. So.
Yeah, thank you so much for that response. I really like how you mentioned that this kind of area wasn't necessarily where you first began, but it really shows the overlap of how multiple disciplines in the engineering field come together to engage in this field and kind of create what it is as we see today. So with that being said, I can hand it over back to Lakshmi.
Thank you. And I think our next question will be going to Francisco, actually. So on the topic of disaster relief, Francisco, what drew you to kind of working in this field exactly? And how did Rutgers help you kind of realize that this is what you wanted to do? And how did Rutgers help you create that foundation to kind of segue for you into your professional journey?
Okay. Well, Lachki, honestly, we were not a disaster relief company. Okay, we had to get involved. Actually, when Hurricane Irma and Maria in September 2017 really hit Puerto Rico, I just want to give you a little bit of background on that. And these were two Category 5 hurricanes, 2 weeks apart. And these were over 150 miles per wind, an hour per wind. And so we were just a specialty contractor working on, like I said, on power, water, and telecom. And we had to kind of we had no choice but to learn. Okay, at that point in time, we had all the skills. Obviously, Rutgers Engineering, I mean, it gave me those tools to, when we talk about in engineering about problem solving and talking about math and physics, what we do. So you kind of like need that as your background when you had so little time to plan. So what actually got us there and learn and with all this background, we were able to obviously get back to the streets and help people and help our power grid and help with the water and help with the communications. And I'll talk a little bit more about that in the next few questions. Okay. But certainly Rutgers what gave me a lot of good tools to be able to work on this disaster relief.
That is really, really interesting. And honestly, as a student, that makes me feel really empowered to know that my education is going to help me like just thrive in situations that I expect, but I also don't expect, because like you said, your company was not exactly in this field of emergency engineering and emergencies, but you found yourself being there because you had a call to that need. So that is really, really interesting. Thank you for that. Evan, do you want to shift us to our next topic?
Yeah. So I know you both mentioned how a lot of your work really centers around disaster relief. So, Dr. Gong, I was really wondering how your research impacted or aided the work done in response to more frequent natural disasters, or how your work has been affected by the occurrence of natural disasters. I know recently in New Brunswick, we were just experienced a lot of flooding from a hurricane that passed nearby. So I was wondering, how have you and the industry been impacted by these more frequent disasters?
I see a lot of the commonality, for my early research looking at the construction side, spatial mapping. So we were working with the LiDAR system, static LiDAR, basically 3D imaging system, tripods. Then later on, when we're working on the transportation projects, we started using the van-based LiDAR mapping systems. So pretty much a Google car type of system, but it maps in 3D information in very high accuracy basic data comes in. So when we actually joined Rutgers and the Sandy hits, I was actually talking to my colleague, one of my colleagues actually, Dr. Ning Ling. She is actually at Princeton University, and we actually did a master together in Texas Tech and Texas Tech University. I mean, somehow we all ended up in this corner of the world here. She was actually doing disaster reconnaissance work at Jersey Shoreline with a group of researchers from the Notre Dame. So I would actually then called her basically, maybe I should come down to look here, or maybe you can help out or something. So I drove down and realized they are doing at that time, doing house-to-house, foot-on-ground surveying, basically looking at damages. So my background basically in spatial mapping, I immediately saying maybe I should call the van-based mapping to just sweep out the entire area. So that idea actually becomes reality. So we actually get a van with LiDAR system map out the entire community, I think many community in the Jersey Shoreline, also New York City. And that is actually the first time, the first large-scale use of mobile mapping for the hurricane events. Actually, it's first time being used over there. So I think basically this work over there, when we talk together with different researchers over there, we realize the solutions out over there provides maybe more efficient way of doing damage assessment to capture the perishable data sets. So since then, we have seen many major hurricane events. We have seen more remote sensing, particularly on the ground, also low altitude mapping system being used over there. I think all these things over there is sort of, we see the potentials of these technologies can really advanced ways so we can categorize the damages over there. Instead of, we have doing this damage assessment for tornadoes or all these things over there back to 1970s, 1960s. And when we actually study at Texas Tech, one of the, I think Dr. Kishore Mehta, he is one of the member of National Academy Engineer. He has actually a room. It's a full stack of these forensic reports from all the tornadoes back in 1960s, 70s over there, just paper documents over there. And it just makes me always wonder, what all these data sets collected over there has been manually been processed and collected over there. So that's actually make me realize the synergy between these large geospatial sensing methods plus the emerging of how to handling these big data sets or its modeling methods can work together, making basically transform the way of assessing damages. So that's basically saying our work over there is further, basically advance this method to how do we do things efficiently, getting more complete view of what happened out over there. So hopefully my response answers the question here. A lot of stories over here I can tell you what triggers these, changes over here.
Yeah, thank you so much for that response. So I know working in your lab as a student, as well as talking to you personally outside of meetings, as well as lab and in the class, that your research has spanned since it began in 2012. So I know that you have had multiple different van iterations. You've been using different technologies. And I was kind of wondering, what are your prospects for this field? Where do you see the future of this field going? What kind of new technology or tools do you see yourself using in the future?
So I would say like one of the best, I think, the testimony to the people seeing the potential of it is like now there's a large scale project we're working on with FEMA and the New Jersey Office of Emergency Management to digitize close to 10,000 miles in New Jersey states, all the properties within the 500 floodplain. That is, I think, the first this kind of large scale project across the United States. I think that why the people want to fund this project to do that, because they see the potential of it. With that, they can get the data set they don't have before. They can do much advanced economic analysis, knowing how to divert the investment to different areas over there to improve the resiliency. So that's why I'm saying the technology is always advancing, but also the way of the data can meet the needs of different stakeholders over there. I mean, I think that is, I would say the technology is we're not just looking at the technology, we have the better technology, but otherwise, if you have a hammer, everything is a nail to your hand, right? To look at that over there. So if we look at needs over there, and then we realize these things can meet that. So I think our way of working with these studies over there is really listen to these practitioners, the agencies over there, and also including like industry practitioners, maybe like Francisco, all these different companies over there. What's the needs over there? What's the gap over there? That is, we can figure out the solutions. We just don't want to technology push. We have this, let's use this. But instead, we look at the needs of agencies over there. We realize the gaps over there. Then this is the opportunity zone, I think. Yeah.
Thank you so much. And I believe Lakshmi is going to be taking the next question.
Yeah, definitely. So we've been seeing a lot of how this work has definitely impacted the United States, especially. But Francisco, you definitely do bring a global perspective to it because a lot of your work is centered around Puerto Rico. So with that being said, how do you see these technologies being used in Puerto Rico? And how do you see these technologies helping your work in Puerto Rico?
Well, I mean, Dr. Gong was talking about mapping and all this technology. We've seen it. I mean, before, back in 20 years ago, hurricanes here were known, but meteorologists just saying what was happening, not with technology that we have today, with the National Center of Hurricane giving us speeds and doing research about it. So it really helped us to provide to enhance our protocols. Okay, we used it when Irma and Maria came. It was something that was part of our protocol, is to follow this technology and through NOAA and the National Center of Hurricanes, see what was the path, what was the risk that we had, what was the probability of hitting our site. So certainly it was a major help, and obviously you have to understand that Puerto Rico, it's very small. Puerto Rico is only 100 miles by 35 miles. Okay, we're a very small island in Puerto Rico, and certainly when these hurricanes hit and such a high wind, we were not prepared. Okay, we were not prepared, even though it, we had Hurricane Hugo in 1988. That's actually when I was at Rutgers. So the resiliency wasn't still out there, except for very small part of the grid that had it, but wasn't there. So one of the really big things that what we did that impacted our communities, obviously, is when we went to the mitigation side after the hurricane, what we had to do. Obviously, like, I say this many times, we don't have I-95. Going to Puerto Rico, there is no I-95, okay? I mean, we can't just call, like Jersey, you can call Connecticut, something happens, you can call Pennsylvania. Here, we were on our own, basically. And one of the first thing, obviously, in the mitigation side, because now we are on the reconstruction side, after so many years, is that what we had to do first. Okay, first of all, our people. Was our people good? Where they were? Can they reach our company? Where can we put our equipment to work? What was the major area that we needed to help the government? So we thought at that time that it was the power and water. You would say that power and water, it's life, especially water. And obviously, if there wasn't power, there wasn't water because of all the pumps. It obviously needed energy. So we started working on that aspect a little bit. As soon as we knew, and when we were having conversations, is that we needed communications. There were no communications. All our wireless and our antennas were down. So everything changed. One thing that both of the hurricanes told us is that communication came first. Because if we can communicate faster, we can mitigate faster. And so we changed the way that we were used to do our protocols, even on our side and on the governmental side, is that communication really reached out to be the first thing that we wanted to restore. So we work on that aspect. We had a bunch of teams working on the fiber side of it, and working with all the providers, and obviously then doing some planning for the grid and the water side. So from our experience, and anyone can have, and if you go to the same situation, just make sure that you attack all of them because it's important for life. But communication, as fast as you restore communication, everything will move faster. One of the best things that we impacted communities here in Puerto Rico is when you see that you can help, that you can provide them a need, and believe me, when you're in disaster relief, you are improvising mostly because there wasn't nothing. I mean, like I said, food was scarce, nothing was open, accessibility to areas was sometimes impossible. So you had to go back to basics, had a team, using common sense, which is important when we're studying engineering. We're so embedded on math and physics. How do we combine them? So, we need sometimes to step back and say, okay, that's important, talking about variables, talking about math, talking about physics. But we need to know how can we use that on our daily lives. And we did, and I'm glad I cannot say it. We had a great team of people working here in Puerto Rico and with us, and our team of almost 60 years of experience here. We know where to go and where to access and have people. So we were blessed. And the best thing that at the end of the day, what kept us very proud is that we were able to help communities and restore order in Puerto Rico to then go to second phase, which will be now reconstruction and reliability and sustainability. We can talk about that now. Back then, it was another story.
Thank you, Francisco. That was honestly very moving to see just like the growth that Puerto Rico has experienced in terms of how they handle emergencies and how engineering plays such a vital role in that. And with that, I wanted to ask you, would you say that Puerto Rico is more prepared now when it comes to facing these types of disasters than it kind of was before? And what was it kind of like seeing that growth?
I do believe we are a little bit better. Okay, we keep learning. However, we will. We are now going back to the drawing board with the codes, more robust codes and construction codes. Okay, to provide communities with better design for house construction. Okay, so we're better, but we are now just developing all those codes. So those standards are now available for the future of Puerto Rico. But we're still probably 7 years to go. Okay, 7 to 10 years to go.
Great. Thank you for that. Evan, can you lead us into the next question?
Yeah. So to give a little bit more background of Puerto Rico's geography and location, so what really makes Puerto Rico vulnerable to hurricanes, and why is this field of engineering and emergencies so important to understand and apply in Puerto Rico?
Well, we are in the Caribbean. I mean, the temperature of the water is like oxygen to fire for hurricanes. Okay, so we get all this wind from the Sahara, from Africa coming in, and it just increases with heat and the heat on the water. So we're on that path. We in the past, I mean, we honestly we would talk about it when I was younger, and we'll talk about it. But now we talk even more. It's like it is like the activity is growing a lot more than what we used to when I was a kid. So it's something now everyone is aware of. Okay, everyone looks into it. We have a humongous protocol here now in the company. We track that. We have people tracking since when the season starts. The season usually starts in June. Okay, it goes all the way to October. So that's getting a little bit of November. So we're tracking all the time, and people are very well aware of them. Okay, and not talking now that we are getting some earthquakes on the south. Okay, so we haven't really been able to get away from disasters.
Yeah, that's definitely something that is very important to take in consideration, that affects everyone. And even in history, we've seen how many communities have been impacted by these hurricanes. And I really like how you mentioned in your previous response how it's really a community effort when you build back these communities using technologies, getting the communication just so everyone can be connected. So in more of like a broader aspect, so how have you seen your work impact the communities in Puerto Rico, and what has your personal impact been?
I mean, I guess, like I said, other than just restoring utilities, you see people that could go back to life and have their normal life. Okay, when I still do remember there was a community that had like 300 houses, and when my guys were actually restoring power, it was something I cannot describe. It's something that everyone just came out the streets and gave them a huge hug and a huge party to them. They were able to try to see a little bit going back to a normal life. So when you do this, you see that there is good people that really are thankful and are grateful. Okay, that there are people that would sacrifice, because we had our people sacrificing families to go and help others. Okay, remember, most of them not even had power in their houses, not even had water in their houses. But what really drove them to go out was actually the passion about helping others. And if we could help others through our people using our skills and our tools and what we learn on our basic principles when we went to school, so it's something that we take for life. Okay, something that we'll take for life. And certainly was very rewarding on that aspect.
Yeah, I think that's an amazing response. I know even in the hurricanes that I've seen in my lifetime, which is only a short 21 years, I've definitely seen how hurricanes have impacted Puerto Rico, and also people have been left without daily necessities for weeks or even months at a time. But I'm really glad that there is people like you that are helping build back these communities so selflessly and improving it that way. And also, welcome back, Dr. Gong. A little bit of connection issues, but glad to see that you are back. So going back to questions we had aligned a little bit earlier in the night. So you were really mentioning about the FEMA project, and I really wanted to bring up my experience working with you in your lab. So we had a lot of scanning over this past summer. We scanned the majority of the New Jersey coastline. So alumnus Francisco Diaz Masso mentioned that Puerto Rico is pretty small, so it's around 3,500 square miles, and I know we did around 6,000 linear miles. So I was wondering, do you think it'd be possible to scan the entirety of Puerto Rico?
It's actually not actually back in Hurricane Maria. I think at that time we were actually was thinking about to put a van on a boat and actually go to Puerto Rico. Actually, was in collaborating a group of researchers from the University of Central Florida, but that idea basically was not materialized because I think the priority is getting the goods or the supplies getting to Puerto Rico rather than getting a van with a mapping equipment. So the logic here is because the number one thing we do when we're doing mapping is don't adding additional, responsibilities or tasks to the local folks over there. So everything that we should be able to self-sustain. So in that sense of I think, in a normal time, yes, it's definitely doable. I think it takes us probably, how fast we can do, right?
Exactly.
We can push 10 hours per day and getting really things, a lot of things can be done.
Yeah, exactly.
Dr. Gong, you're welcome to come down and map Puerto Rico, and you have a place to stay and to work.
Yeah, I would actually want to also follow a bit on the question when Francisco, you mentioned improvise in the field. But that's the thing I cannot agree more on emergency in the field. And I was like, I can tell you my experience with Hurricane, I think Michael in Florida. So we actually oftentimes we always organize a group of students heading down with other schools, different students over there, heading to the actually this hurricane impact site to doing mapping, documenting the damages over there. Hurricane Michael is one of them give us of the most of the challenges, if not the most. The issue is when we went down there and our battery system on the van is dead. Basically, we have a lot of battery system in the van, so it's dead. And there's no solution for that because we cannot boot it up. So, but luckily, one of students always bring a backup generator. So what do? We put a generator on top of vans. On top of van, we keep mapping, and but still, that's not the end of story. So we did a couple of half day mapping. We hit a nail because one thing we just learned over there: any kind of disaster mapping, you are bound to have flat tires. And I can, Evan is smiling. I know he is almost call him king of flat tire because he is doing mapping. He flat tire 2 times already on my team.
Yeah, 2 times in 1 week.
1 week, yeah, and because on coastline, the construction zone, don't even to mention this disaster zone, there just so many nails on the ground. So, but in that case, the Hurricane Michael, we're lucky to have a student actually he knows how to plug the tire. So we have this plug actually get the wheels off, couple of them, the plug that in, patch it up, move on. So we actually did 2 flat tires in Hurricane Michael, and it's such a great experience for students knowing actually in the field you have to improvise, you have to be versatile, and you have to be handy. And as engineering student, if you're knowing these traits over there, you will be safe in the construction side, any kind of engineering job out in the field.
Certainly.
Exactly. And I know you mentioned how we did a lot of the work over this past summer, and we were in a lot of areas that were currently being built back from either Hurricane Sandy or any other recent kind of disaster or flooding. So when I was doing the work out in the field, scanning the multiple coastal communities, there was a lot of friends asking, or not friends, a lot of people in the communities asking about like the van, and then I explained them what to do, and some of them even thanked me. So I was wondering, what impact has this research like meant to you, and what impact do you think it has done to the communities? Because personally, in my experience, I mean, I've been said thank you multiple times. I've had people wave, and it's definitely impacted me, like hit my heart in a few different locations. So I was wondering what it really means to you.
I think it's two-way streets, and at least there is another experience when we did a Hurricane Harvey, which in Texas Rockport, which is 3,000 miles away, and we actually have a team going down together with Princeton team, with the Texas team. So 3 teams going down converge over there. And actually, the experience I want to share is basically it's a community called Bayside. It's a Bayside community above the lake over there. So it's such a small community, and no one actually went to there. So we drive a van going over there, mapping the community over there. When you drive that van, you even think about, am I at the right place? Because this is the town. It's a ghost town. Everything destroyed, and no one there are stray dogs in the woods over there. All these things over there. So you feel like this is exactly the side the Hollywood gonna feel in this ghost town like movies. So I'm doing mappings over there, and suddenly from one of homes emerges a senior couple. Okay, a senior couple with guns. So it's a bit in Texas, right? So because they look at us and talked with us, and eventually we had a very nice and engaging conversation. Basically said, this town's actually, we have about 300 residents, and most able and basically young folks already left the town because they're moving out for jobs over there. So this town is really in bad shape, and most people, you see the different township make us over there. When doing the mapping, you understand what they call it, like I think the disparity, the equity along different communities over there. And this senior couple actually told us, you know what, the entire town over there, you are the first team coming here doing the mapping, and no one can see it because we only have 2 votes. The entire township, we only have 2 votes. We only have 2 registered people vote. So that gives you an indication of you're starting understanding a lot of different things, structural issues, also the social other issues over there. So that is basically to them. We going down is from all the way to New Jersey doing mapping, look at damages over there. It's I always say it's heartwarming for them, and I think to us it also means a lot basically.
Yeah, that's.
Oh, sorry, go ahead.
I was just going to say that's exactly what I felt over the summer working with you in your lab. But Lakshmi, take it away.
Thank you. Wow, Francisco and Dr. Gong, you guys have really impactful stories, honestly. It's very heartwarming to see that you guys are growing so much in your work, but your work is also impacting so many people that you're serving. And with that, I wanted to kind of know a little bit more on the technical side about the technology that's definitely grown in this field overall. You guys have seen so many advancements during your time. Is there like a specific piece of technology that you've seen implemented that has made disaster response more effective now?
Well, I mean, what I told you before, I mean, we in our protocol, I mean, we watch the National Hurricane Center mappings. We watch NOAA. It gives us very good information, about probabilities and the mapping. So it certainly gave us that tool to plan. To plan, like I said, we plan for the worst, we hope for the best. So yeah, technology it has certainly helped us obviously do better planning with our protocols.
And to my side, I think I think if we technology includes, I think these training methods of the data science and artificial intelligence, I would definitely think that data science and AI would be things that ranked very on top of the list in terms of, because I don't think we lack of methods to capture the data, but in the sense of to make sense of data, we still lags. I mean, we are still lag very behind in terms of, because it's just so big, this volume of data sets, and it's not like you being collected, house by house, easily being analyzed. It's a lot of the, I think, additional or redundancy data, and also not, I think just a lot of, I think, noise in the data sets over there. So I would say the data analytics, data science, and also these AI tools. Of course, we have to consider the domain knowledge, how to make sense of this data is really me at the top of my, I think, my wish list. Have this method being able to make sense of this data be collected, basically.
That's really interesting to hear. And I feel like over the years, there's been so much change going on that there must have been some challenges that kind of came with implementing these new protocols and these new ideas and kind of getting all that off the ground. So to both you, Francisco, and as well you, Dr. Gong, what has been kind of the most challenging aspect that you've had to deal with during your time that you're working in emergency disaster response?
Well, like I said, on our aspect on disaster relief, when Irma and Maria came, was actually we're on an island. There was no I-95, and getting any equipment, any materials down here was very difficult. And to improvise and to work with what you have and understand the needs and put all those variables together and come up with a better strategy to provide the best available solution at that point in time. So I think something we take back, and it's something we wrote in our protocol. It's something that when you go out and you see how are people sacrificing their families, and when there are people dying, because there were over 3,000 deaths in Puerto Rico at that time, when you got hospitals not working. So how do you do it? And certainly at the end of the day, it's about people. It's about obviously your leadership with all the tools, like I said, we had, and I think the most important one was like we have a very good team of people here, very good engineers, local engineers, stateside engineers, and people that really want to work. And obviously that commitment and that teamwork that we do experience when we are doing projects. And I still do remember in Rutgers, one of the things that he was always there was work as a teamwork and do projects every semester for every different type of lectures and classes. And so it's something that helped my interpersonal relationship to work with others and talk at the same language and talk about the needs and talk about how the technical side of what we did learn, we can put it to work. And that's what we did. And it was very grateful that we did that.
That's wonderful. What about you, Dr. Gong?
To me, I think it's I was still gonna to focus that at the turn of uncertainty. So when you're working with emergency, particularly natural disaster, it just a lot of uncertainties, like from the whether from way of you organize a reconnaissance trip. It's just a lot of uncertainties can happen, and you cannot predict them, and you have to deal with uncertainties, and also have basically have students prepared for the uncertainties. And also, I think when we analyzing these, whatever the data we collected over there, we also face a lot of uncertainties. So I would say the challenge is always in the uncertainties, and so to some cases that was always mentioned, for the Texas trip when we went over there, we cannot find hotels, and some folks have to live on the beach in a tent. Because you just think about how hotels are being taken out, and it's being relieved over there, but it's I certainly it's challenging, but also it's greatest moment for team building basically. But when you have a group of students or any employees working through this most challenging moment with that, so you come out a great team basically, and the people really know each other and have each other's back. So I think that's challenging, but also most rewarding, this environment, and it really forges a team and opens eyes of students about these uncertainties.
Yeah, Dr. Gung, I'm really glad you mentioned that topic of uncertainty. So I know over this summer, with all of the flat tires, the technology sometimes not being our best friend, that it really became a moment where the team came together. We all helped to get the new tire on, to help each other, call each other up, and see what was happening with the laptop in the van. But also going back to the topic of uncertainty, and how with natural disasters, you never really know who and how the people of each community are going to be affected. So with the recent flooding we had in New Brunswick and across New Jersey, some areas we didn't know were going to be flooded became flooded. And with the hurricane that touched down near the beach, we had just scanned there earlier in that month, and then later on we were able to go back and compare data. And that kind of uncertainty, kind of the randomness, is really something that definitely plays a factor into how engineering and emergencies plays an important role, because it is uncertain, and we kind of build off of that to create a better field and technology to base off of that. And so kind of going off of that, so we were wondering, so in both of your time, so Francisco and Dr. Gong, what has been kind of a memorable experience? I know, Dr. Gong, you mentioned how some of your team members did sleep in tents on the beaches, but what were some memorable experience that you have shared in your time since joining Rutgers, and Francisco, your time in Puerto Rico?
Well, I mean, I had a lot of memorable times in Rutgers. It was great. Obviously, the learning side and being able to be challenged on all this math and physics and all this technical side was important. But one of the best ones was actually understanding back then technology and dealing with computer aided design. That was a challenge for me back then. Going in, and when we was the early stages in the 80s, dealing with supercomputers and putting the amount of time that we did to just drew a small block, and you guys do it now like in 30 seconds, and it took us like 4 days. Put like 30 hours into it. Remember, it was actually, I had to build an engine, an airplane engine, and it took me so many hours. And nowadays they do it so fast. So it was a memorable time, just putting amount of time in the lab and the endless hours at night just to get it done. But the best thing is that also it's about team. It's about team. I'm very thankful that I was able to work with good people and people that were passionate with what they were doing, and my teams and my guys, and we were able to get it together, and that's why I graduated. That's why I became a mechanical engineer, but I can say it was that interpersonal relationship and that firsthand on computers and technology to get me going.
Yeah, I'm glad you mentioned that. Also, kind of ironic that you mentioned it as well, because Lakshmi and I are the generation that grew up with computers, and it still takes us a few hours to complete assignments, just like that. So, giving it back to Dr. Gong, so what were some of your memorable experiences?
Most memorable, I just have been like, if I look back, it's the most memorable experience. It's so many of them. I would say all the students have been working with and just been like really blessed to work with them, and some of them already just graduated and working for different companies. And I think when I recounted the times we actually is spending in the field, it's very in the field, assessing the damages. Then when they see the destructions happens in different communities, in Florida, in Texas, in Jersey shoreline, and you can see the transformation in the view of the civil engineering, basically. And that is to me, it's every moment of them is memorable. And if I have to say, it's these things I can countless to say for many of students, even for the, I think for the, which one? For the Harvey, it's a particular harder one, because for us it's 3,000 miles down, and it's 3,000 miles back. And it's one of the community, actually, was called a Kia Alagro. It's one community. I was still remember that community. It's a gated community. It's every home of that. I mean, as average house value is about I think $600,000. In Texas, Lockport, $600,000. It's a lot. I mean, it's very almost like very rich communities. It's gated community. So we've been trying to getting over that, look at how this West community was damaged compared to other communities over there. The first time want to get in, we go to gate over there. We told them what do we do? No, you cannot get in. So we turned away. And the second day, we try again. Try two different people drive the van comes in. No, you cannot get in. And the third time, on Saturday we try again. So this time they look at us. Okay, you guys come in. So we get in, but you know what happened? After driving the community about 1 minute, one of the sensors on the van broke down. So we didn't capture that data really well on that community. So it's like this memories flashed me over there. Just think about it as engineers, persistence, right? We want to know these well-built homes, how they perform compared to ways being not poorly, not so well-built, the community. Yes, I mean, that's a research question for us to, address. But we don't have data set, but we take persistence, basically, 1 time, 2 times, third time. I think that's this experience, I think it really get students knows you have to try multiple times, basically. Right, in order to validate whatever your research hypothesis is, and it doesn't, I think, be really fresh memory in my memory each day. Looking at these projects, basically.
It's really interesting to hear your both memorable experiences in this field and how they're kind of similar, but they're also really different, which I thought was really interesting. So we actually do have a question from somebody in the audience, Ricardo. And fun fact, he was also there at the Puerto Rico site after Maria hit, and he got to help with the cleanup. So Ricardo's question was, how does Puerto Rico account for the increase in earthquake swarms?
I'm sorry, can you repeat it? How Puerto Rico is?
Yeah, how does Puerto Rico account for the increase in earthquake swarms?
Well, on the earthquakes, it's it's the first time that on my experience that we have had this type of natural disaster. It's actually in the south. We were not. It was more structural damage, and not a lot on infrastructure of what we did. And so it's there was some damage out there. I'm not sure about accountability, but know that there's plaques, the Caribbean plaques that they're moving, especially and they are on the south part and some of between Puerto Rico and Dominican Republic. So there was some movement there, and that was really what accounted for those epicenters on the south. Basically, that's what I can say.
Oh, okay, that's really, really interesting. Thank you. So you both have had definitely like really memorable experiences, and I just really would like to know, at least as a student, I definitely know that, you know, going into industry is the next step, at least for me. And I know that there are several friends of mine who want to reach out and go into academia, and we're all really interested in making an impact with the work that we do, especially in civil. So with that being said, do you have any potential advice that you would give to students who wish to enter this type of field of work?
Well, one thing I can say is be passionate. Be passionate. Understand the basic principles. Have that common sense. And what's unique about on the field that I'm in the construction side is that every decision is tangible. The decisions that we make, we can see them. Okay, so when you're building anything, the decisions that you make as an engineer on a drawing board, you will be able to see it. You will be able to touch it later on. So that's what I can say. I mean, it's about commitment and be passionate that you really want to do it well.
From my side, I think, as civil engineers, I believe because one of the core tasks for us is design and build things. Because we build things. That's one of the most important things we do. We build the civil structures over there. And much of the civil structure still the performance cannot be simulated in the lab, in the real world over there. So it's imperative for students to go out to see in the field how structure perform, past structures being designed and performed during extreme events. And that's opened the view of how structure perform under this spectacular force of wind and water, wave, all the different phenomena over there. So that's one of the wise things. Basically, try to don't be afraid of that field component. You should embrace that field component in the field to understand how structure performs. And the second, otherwise, I think is like each of the discipline is I think is working with increasing amount of data. The data driven, data is more and more come out of that. So I would think students have a good data skills to consider a minor in information science or data analytics over there can go really far in terms of to make use of data efficiently.
Thank you for that. Evan, can you, actually, we do have an audience question from Adlin. Adlin asks, is there anything that can be done preemptively if it's known that there will be a natural disaster? Like, is there any preparation that can be done before the natural disaster is expected to hit?
Yes. Now, certainly, you on our side, on our protocols. I mean, when now that we know that we're gonna hit the season, that we know, so we do checks on our equipment. We make sure that we have enough materials, in the house Puerto Rico, and our inventory, and we train our people now where we're gonna meet, what's gonna happen, how to use the communication more effectively. So there is a lot of pre-planning you can do. Make sure that the areas are clean, within the company and within the areas where we work, have all our projects clean all the time, and something that we do now. We're more robust about it. So yeah, certainly there is a lot to talk about. There's a lot to talk about.
I would say yes. I mean, depending on the type of natural events. If we talk about earthquake, it's very hard because reaction time is so short. But if we talk of wind events like hurricane events, and we have a window definitely for preparation. The actual FEMA, all these agencies, they're doing pre-positioning of these, post-disaster recovery assets. The pre-positioning then according to the projection. What is really difficult to do is the human behavior part. Even in many communities you will see, even in the evacuation zone, they still choose to stay. And because of the, whether it's be belief, whether be the how trust of this, how accurate this forecast can be. Certainly it can be improved, but still we will see, even we know it's gonna hit them, we're gonna see very difficult times to convincing people to evacuate in many cases. So it's a complicated problem. Just it's not they don't want to evacuate. For many people, poor community, they don't have people. They don't have place to evacuate too. It's a simple question like why don't they evacuate? The question could be answered could be just they don't have place to evacuate too. So there are many things over that we know we can do, but it requires a lot of system level to make it happen. So that's why each disaster when we see strike, and we still have see a tremendous loss over there. Much of them can be reduced if we have a better understanding of these human systems, basically.
Mm-hmm. I agree. I was talking more about hurricanes, but I completely agree with Dr. Long. Earthquakes, preparedness, it's almost impossible.
Yeah, so we have 2 more minutes remaining. I'm going to ask one final question, then we can wrap up. So, as kind of the final question, so Francisco, as an alum, so what kind of skills did the School of Engineering prepare you with that you brought into a professional career? And then Dr. Gong, if you want to follow up by answering, what kind of skills have you gained during joining the School of Engineering that has helped you in your professional career?
Well, like I said before, and I keep stressing it because it's part of our life, to be able to solve problems and provide solutions. Obviously, you need those basic skills of math and physics when you're an engineer. But there's something human side of it, which is teamwork, which working in relationship with other people. And that's something I take very hard. It's something that really helped me in my life. I've been able to put a team together in the company, which is a lot of people. I'm blessed that we work together. I have family. I have my sister. She's an engineer, and I have other people, and we're all. It's a team effort at the end of the day. Okay, so if I'm gonna take something, I will say it was obviously a technical side of it because it was so important on what we do as engineers. But on the human side, it's how do you work with other people and you be able to use your reason and talk about things that will work together on the positive side of bringing solutions together. That's what I would say.
For my side, I was like, certainly over the past 10 years, we have seen a lot of investment from the school level, like university level, into the systems, technology, equipment is definitely happening tremendously in terms of setup. Actually, my research program, also the broader research programs over there. But one thing I was thinking I really learned a lot during like Rutgers is actually I'm starting understanding how to convince you guys join these research groups. So we need a good student to contribute into these groups over there. So that's fundamental thing has basically how to working with students more in a better way and in a motivated way over that means. So that's the best thing I learned basically in terms of working with students.
Thank you so much for your responses. And it is 6 o'clock, so we are pretty much right at the end of our event. Thank you, everybody who came out today, and a big thank you, of course, to Francisco and Dr. Gong for taking the time to talk about your experiences and talk with Evan and I about all the skills that you gained, the experiences you've had, the number of flat tires you've apparently have had to change when you're out in the field. All of these experiences have definitely been really important to learn about, and I can definitely say that I've learned something at the end of this panel. So big thank you to everybody, and I hope you all have a very good evening.